My name is Frank Meyer from a company called CeraNovis in Saarbrücken, Germany. We are in the field of nanoceramic coatings, which are used in heat processing environment. We are an SME with 16 people. We have a full range of potential applications for us. We do research for companies. We do research for the government. We also develop, produce, and sell coatings, which is our bread and butter business. Our coatings are to be found in a couple of applications. We use non-stick coatings and melt repellent coatings in the cast house field, especially where liquid aluminum is treated. We also have coatings which go into foundry and cold box business, where we coat low pressure die casting machines where aluminum is cast, and also brass. We also coat thermal systems where flue gas is transported and causes problems. And we also coat components, especially heat exchangers, with nanoceramic coatings, where I now will talk about in the next few minutes. This is the chemistry behind our system. We make sprayable, dippable, or coatings that can be flooded. Our solvent is water or a solvent. We use nanoparticle binders. Some of them we make by ourselves, some we buy. Besides the binders, we also work with fillers and with additives. And of course, we are in a position to disperse these particles and all these fillers into a very good matrix. So we work a lot with ball parallel mills. We work a lot with attributors, so with dispersing aids and with a lot of materials that are heavy to disperse. So what are some of our products using this nanoceramic binder? And first of all, why use a nanoceramic binder? A nanobinder has the property to sinter at much lower temperatures compared to a conventional ceramic binder. So we can coat metals at much lower temperatures with a ceramic coating. That's basically the secret behind it. One of our coatings that we're using is a coating called NP-Ice-10. It's used in automotive components, and it's used on heat exchangers for whiteware, for tumblers. It's an anti-stick and anti-dust coating that is used on heat exchangers and keeps them clean, keeps them efficient. The coating is very thin. It's applied by dipping or by spraying. It's thermally stable up to 250 degrees C, and it's cured by temperature. This can be found currently in serial production in heat exchangers for a major German producer of whiteware, in the tumblers, in the dryers for clothing. Another coating which we use for heat exchangers is called Alsicor. It's a material that is used on heatings and domestic heatings in the fuel chambers, especially in the burning chambers of heatings for gas and for oil, and it's used to protect the heat exchanger against corrosion under high temperatures and under strong chemical attack. The flue gas is cooled down, and the flue gas produces acids upon cooling down, like sulfuric acid or nitric acid, and our coating protects the heat exchanger for over the lifetime of the heat exchanger against the attack of this acid. And also, it's a very thin layer which cures at low temperature. It doesn't have any influence on the heat exchanger's properties, and it protects and keeps the heat exchangers clean for quite some time. Here you can see some pictures. Yes, so these are the typical pins for such a heat exchanger. Underneath, you see a cross cut. To the right, you see the metal. To the left, you see here the coating. The coating is less than 50 micrometers. It's very thin. It doesn't impede heat transfer. And to the right, you see how this looks with regard to adhesion on an aluminum surface. It's very well adhering, and it's very well doing with regard to adhesion to the metallic substrate. So that's basically all I wanted to tell today with regards to the pitching session. Feel free to copy my contact data. I'm also having a profile on the Micronora homepage, or on the conference homepage, where you can contact me and write me a message, and I will respond for a direct talk on behalf of our nanoceramic materials. That's basically from my side. Thank you very much for having the opportunity to pitch here, and you're welcome to feel free to ask me any questions after the session. Thank you very much.